Hello everyone. I'm going to talk to you a little bit about Kubernetes. Does everyone know Kubernetes?
Yeah. What's Kubernetes?
That's a long story. I'm Neil, the CEO and co-founder of Portainer. You may or may not have heard of us. We've been around a while, previously as a Docker tool, but we spent millions making it work for Kubernetes and Nomad. So it's a pretty cool tool if you want to get started with containers. You don't know how to begin. You've had your past life as a VMware engineer or VM engineer, and you're like, how do I make this transition? That was me. That is still me, and I built Portainer to help me transition from an infrastructure person to a containery person. So it helps me that. It'll help you do the same thing. We're a commercial open source company, which is something most open source people find horrific. However, open source has to be funded. We have 700,000 users of our open source product. Monthly users, I might add. So pretty widely adopted. I have at many times been sitting in restaurants in far-flung reaches of the earth, and people behind me are talking about Portainer. So it staggers me. I'm from New Zealand. Portainer was built in New Zealand. That is a long way away from anywhere and everywhere. And to be somewhere in the world hearing someone talk about Portainer is pretty cool. That's the power of open source, by the way. Unbelievable spread. Our whole goal is to make the adoption of this technology ridiculously simple. Sometimes I'm a lone voice. I like to make Kubernetes boring. I believe that we've kind of lost sight, and Kubernetes is tech for tech's sake, as opposed to tech to deliver business outcomes. So I'm trying to make Kubernetes as boring as possible so you can just use it. I don't like the fact that a full stack dev now basically means an IT department and a person. I think that's gone a little bit too crazy, so we're trying to make it simple. The best way to depict this, two different spacecraft. You think the one on that side, the right, the left, whichever you look at it, is any more or any less complicated than the one on this side? Definitely not. It's probably far more. You can in fact put a button that says return to Earth and you return to Earth. We do the same thing. So we take the craziness that is the CNCF landscape with all of its now 1,200 discrete products that you need to use Kubernetes in production, and we say this is crazy, let's try and put this into Portainer and have just a one-stop shop to get everything running for you. I'm not going to try and sell you Portainer, that's not the point. Have a play. MicroK8s, do you guys use it?
Yep. Totally.
Awesome. I have to say it's probably the best on-prem way to deploy Kubernetes by far and large. You can go and use kubeadm, you can go and use Rancher, you can go and use all these other products to spin you up something. They get you into trouble quickly because they are taking away a lot of the complexity of setting up a cluster, but they still set you up a fully featured, fully managed, multi-component Kubernetes cluster with all of the bells and whistles that all of the cloud providers have and use, except you don't know how they did that and you don't know how to triage it. So unless you know how to do Kubernetes the hard way, you shouldn't be trying to do Kubernetes the easy way. You'll just be in trouble in 3, 6, 12 months time. MicroK8s is different, single binary bundled, it just works. Very simple, snap install MicroK8s, snap refresh MicroK8s to upgrade it, MicroK8s add node to expand it, MicroK8s inspect to troubleshoot it. It is ridiculously simple to deploy, scale, troubleshoot. So if you have to do Kubernetes on premises, I would say only really consider MicroK8s. 100% supported, production ready. It's designed for the edge, but I would say that it is actually underselling itself. I think it's designed for on-prem. Now it is resource optimized for edge, but that doesn't matter. You can use it anywhere. With Kubernetes, managing one cluster is easy. I'm going to put easy in speech marks, but it's easy. You don't have to worry about things like authentication. You don't have to worry about all of the complexities that multi-cluster management entails. So managing one instance is easy, but one instance does not equal edge. So if you're looking at an edge scale deployment of Kubernetes, you will have dozens and dozens and dozens of clusters. We have customers who run hundreds of clusters, small, either 1 or 3 node clusters to run factory floors, to run point of sale and retail, computer vision, hundreds and hundreds and hundreds of thousands. We're in fact testing with someone right now who's rolling out 5,000 clusters. How do you manage 5,000 Kubernetes clusters? Lots of coffee. So edge means multi-cluster, which means complexity. All these things on this little Scrabble chart here are things you need to consider. If you don't consider these, you'll get yourself in trouble. Networking, how do you have consistent networking across all the clusters? How do you manage them? How do you ensure compliance, security, governance, control, audit? The last thing you want is a exposed Kubernetes instance. I think at the last securities research survey, there were over 50,000 Kubernetes clusters that were publicly exposed and accessible, open APIs. That's crazy. I went to a session yesterday around how easy it is to breach Kubernetes, and it's simply running commands against an open API, reading cert files back from the open API. You've now got cert files, you now have admin access to the cluster, and you've got access to anything. The reason that happens is Kubernetes out of the box is, I'm not going to say insecure, it's not secured. There's a difference. It expects you to know what you're doing, it expects you to connect to the cluster, configure the cluster, and configure security. If you don't, it's not secured, therefore it's insecure. So there's a bunch of complexities you need to think about. Again, if you've got one cluster inside your private network, probably okay. When you've got hundreds or thousands of clusters, some connected to 4G networks potentially, you have yourself a problem and a headache. So all these things you need to think through. So how do we help MicroK8s adoption? And I'm being very specific there, helping MicroK8s adoption, just because I love it so much. So multi-cluster builds. If you have to go and build a lot of clusters, you need to do so in a way that's really simple, really fast, repeatable, consistent. And so inside Portainer, we have the ability to build clusters. Now we've got the cloud provider clusters, as you can imagine, but we've also now recently added support, and this is a PR build, so you can play with the PR after this. So inside this PR build, you now deploy MicroK8s. You simply put in your credentials, and we will connect to the remote Linux servers, install MicroK8s, configure the cluster, install all the add-ons, do everything you need to do, lock it down, secure it, and then hand it back to Portainer for someone to go and deploy apps to. So it's really, really, really quick. It takes a few minutes max. In fact, I've got a demo here to show you as we do it. So here we start off with no environments. We go to our Kubernetes as a service, choose MicroK8s, give it a name, choose how many nodes you want it to have. This PR supports 1 node or 3 nodes because it's designed primarily for the edge, but we're going to change that. Choose the add-ons that you want to deploy and click provision. We will then go and connect to that remote environment and do everything that I said before. So connect to it, install, snap install MicroK8s, configure the cluster, connect to it, off it goes, and you come in to Portainer now. We had no environments before, now we have one, the cluster. You can come into the cluster and you can deploy applications manager. Again, if you haven't seen Portainer before, it's this beautiful UI that makes it really simple to deploy and manage anything in Kubernetes or Docker or Nomad. You can use code or you can use no code if you want. So we have a form and we have code for anything and everything. So really simple way to spin up a cluster. The second thing we're working on is centralized authorization. So if you have lots and lots of clusters, you need to have a key for each of those clusters. In Kubernetes, that's a kubeconfig file or a config file. You need to have one of those for each of the clusters. That gets a little bit ungainly if you have hundreds or thousands of clusters to manage. So what we've done is built ourselves a full Kube API proxy. So Portainer acts as a singular API endpoint for Kubernetes, and we then proxy through to however many backends you need. So if you have 10, 100, 1,000 Kubernetes clusters, they all are proxied through Portainer in a safe and secure way. And we do this by having centralized authentication and RBAC. So inside Portainer, you can connect here. I've got a whole bunch more clusters now. You can come into Portainer, you can add users, either in our own directory service, or you can link Portainer to your upstream directory, LDAP, or OAuth. You create users, you can create groups of environments, so groups of clusters. So you say, I want a Kubernetes group, or you could have a US group, a EU group, a prod group, a dev group, call it what you like. You can then come into that group, manage access to it, or you can actually manage access at the host level as well if you want, or the cluster level. But come into the environment, choose a user and assign them a role. We again take care of creating all of the RBAC roles and role bindings. If you have played with RBAC in Kubernetes, you'll know that it's troublesome. If you get the verbs wrong, you can have unintended consequences. Famously, Darren from Rancher, the co-founder of Rancher previously, he posted something and he said, after all my years working with Kubernetes, I didn't realize that if I use this particular verb, I've now given that user the ability to change their own RBAC roles. And he's like, I've been working with Kubernetes for years and I only just learned this. So here, logging in as the user, as you can see, the theme changed to dark mode for that user. But so logged into the user, this user has access to just a singular namespace because they were given access to the cluster, but nothing else. So it means they have access only to the default namespace. You can log back in as the admin, and you can say, actually, for this user, I want them to have access to more than just the default namespace. I also want them to have access to a namespace for them, for their team, for the application, whatever you want. So here we're creating a namespace as the admin in Portainer, turning off quotas for the demo. And then once we have a namespace, you can manage access on that namespace, and now you can grant access to that namespace for the user. So by default, the user has access only to the default namespace, nothing else. So the user has access to that namespace, log off, log on as the user again, and now they can see both the default namespace and their one. Also, by the way, using the default namespace is a terrible idea. So we also let you turn off access to the default namespace. And if you do that, when the user logs in, they see nothing. They can log into the cluster, but they have no access to anything. So here we go, they've logged in, they've got 2 namespaces available now for them to go and consume. So pretty simple way to centrally govern access through RBAC. So centralized access is another one, right? So again, as I was saying before, Portainer is an API proxy. So you want to be able to aggregate control. Again, this is really important if you're using third-party tools that want to connect. Like if your devs have access or use VS Code and they want to VS Code directly to the clusters, you either have to maintain all of those kubeconfig files. And remember, kubeconfig files normally expire, so that very rarely in production would you find an admin crazy enough to say, here is a non-expiring kubeconfig file. So if they expire, that means they have to keep rotating them, and so it might drive the devs crazy. So this is a way to say, here is a singular kubeconfig file for all of the clusters, and it proxies through Portainer. And again, this is trying to make mass use of Kubernetes easy. If you have Kubernetes environments that are out there on the internet behind 4G modems or whatever else, carrier grade NAT, you can't actually get to the exposed API. We also have an agent that runs in the cluster that will connect the remote environment with Portainer in a reverse tunnel way. So you can still connect to just Portainer as the API endpoint, and that API endpoint will then open the tunnel and connect to the remote cluster securely and then proxy the kube commands through. So you can see here in Portainer, you connect as a user, you download your central kubeconfig file. Once you've got your kubeconfig file, you can have a look at it here, and you'll see that all of the endpoints share the same URL, the MicroK8s.portainer.io in this case. So they all share that same API endpoint for all of the clusters. And then from my local kubectl on my machine, or if you wanted to use OpenLens or Headlamp or VS Code or whatever else you wanted to, you could import this config file, and you can do kubectl, get get contexts. You can see the clusters you have access to in case here's 10 MicroK8s clusters. And from these here, you can kubectl get nodes, and it will go and connect through Portainer proxy to the back end and get you the node count. In this case, it's just a single node cluster. So it makes it really, really simple to try and connect multiple environments together. Are you following? Am I going too fast? No? So challenge number 4 is consistent deployments en masse. So there are 2 ways to handle mass deployments. One way is GitOps everywhere. So you go and have a product like Argo or Flux, and you GitOps everything. You have to go and install an agent in all of the clusters, and you connect them all back to a single GitOps or a Git repo, and you manage them that way. It's a bit what Rancher Fleet does. Portainer has something very similar, where all of the remote environments are managed and governed by the central Portainer instance. From that central instance, we can say, take this application manifest, and deploy it to all of these environments. And Portainer will go out to each of those environments and deploy the application concurrently. So we've tested this up to 1,500 remote clusters in a single group, and we're scaling that even further. So we've just purchased an Azure subscription for 50,000 nodes, so we can test against 50,000 nodes. Don't ask how much that costs. It's too much money is the answer. We had to get special approval from our local Microsoft office for that many nodes, because we only want them for a week, a month. And they're like, well, we have to guarantee them to you for a week, a month, which means we can't sell them for the other 3. That's the benefit of cloud. That's your problem, not mine. Anyway, so using Portainer, you can see here I've got 3 groups. Each group had 15 clusters in the group. Right, so a total of 45 clusters out there in the world. I can come in and say I want to deploy Nginx, just because that's the easiest one to deploy. Nginx on the Nginx group. So take this Nginx manifest file, which you can get from Git, or you can just paste in. I'm just pasting it in to be lazy. Paste it in and say go and deploy, and it will go and deploy to those 15 clusters simultaneously. If a node is offline for whatever reason, so let's say that it's a mobile device and it's currently off, when that device connects the next time, it'll say, hang on a second, I'm missing something, go get me my update, and it will deploy it. So eventually, 15 on the blue will turn to 15 to green. 15 on the blue says job pending, green says job executed, and you'll see that all of the MicroK8s nodes are now going to go and run that application out there 15 times. You do the same thing here with another group. So I've got a Redis stack which will deploy on another 15, and I have another stack which will deploy another 15. So you can just go and push it out in a really simple way. This is already used in production at scale for a lot of customers already. People who are managing factory floors, who are managing IoT applications, they want to say, here is my IoT app, push it out to all these IoT devices. All of this stuff, by the way, I'm showing you is available in the open source version. So don't worry that I'm trying to bait and switch you to a paid version. It's on the open source as well. About 90% of the features are in the open source version. We basically moved quality of life features into the paid version to try and get some delta. So you see here, with this is MySQL. It's got a persistent volume, and eventually you'll see all 3 of them will be running, and all 3 will be green dots, which means the application is running. 3 applications are running in 3 groups of 15 nodes. Now, if, for example, I wanted to add a 16th node, I could just go and build a new MicroK8s cluster, add it to the group. Instantaneously, that cluster will be told, hey, you need to be running this app, go run it. So it'll just immediately source it and run it. Also, you can we have, if you're trying to run Nginx across this group and this group combined at the same time, we're smart enough to say, hang on a second, it's the same thing. I'm not going to run 2 copies of it. Unless there's a difference, then we will run 2 copies of it. So there's some different deltering going on there. So that's how we manage this at scale. Try and make it really simple to run at scale. And the main thing really there is to just radically take away the complexity of managing Kubernetes, radically taken the way of managing authorization, access control, central governance, and policy. The other thing we have in here is support for Open Policy Agent, so OPA Gatekeeper. So if you needed to, you could say, I actually want to enable OPA on all of these Kubernetes clusters, and we'll go and deploy and configure OPA for you, and we'll define OPA policies. So again, you can control and govern everything centrally. So this is a private build right now, or a public build, a PR. We'll be merging and releasing the MicroK8s, native MicroK8s support around December. So if this is of interest, you can play with the private build, which is there. So PR2323, so Portainer CI. And if you want to try the business version of the product, I have a license key, which I will put in the notes after this talk as well. So the business version, this is a 90-day license you can use and play with to just go and spin up and try. Again, that's just quality of life things. For example, GitOps enforcement. So GitOps will just say go and deploy. GitOps enforcement says don't allow anyone to make a change, always override their change. So encourage you to have a play, encourage you to look at MicroK8s, and don't fall into the trap of going and looking at the CNCF landscape and getting a dart and throwing it and trying to choose which products. One thing that I would say is with the current economy, there are a lot of open source projects that are beginning to struggle. I would say we will see some consolidation of the CNCF landscape, my bet, in the next 18 months. Very few people understand how much it costs to actually release a product for free. It's a lot of money, and that has to be funded somehow. It's funded predominantly by VCs, and VCs eventually expect a return. So that's why everyone eventually has to commercialize open source through either paid support or something else. And so if you don't, when the economy starts to tighten, VC money dries up and things consolidate. So be very, very careful with the CNCF landscape. There are literally hundreds of projects that do the same thing. So it's very hard to know which one will be there in 12, 18 months' time. So that's my word of advice on that one. In regards to Canonical's Kubernetes, you've obviously, I've talked about MicroK8s. There is also Charmed Kubernetes. I don't know if any of you have used Charmed Kubernetes. It's pretty big. It's basically, I would say, Canonical's version of OpenStack. OpenShift, sorry. Not OpenStack, OpenShift. So if you want to run your own distro, so the Canonical distro on any cloud provider or on-prem, then you can look at Charmed Kubernetes. It's basically MicroK8s' big brother. So if you look at footprint, MicroK8s is pretty quick and simple to get up. Charmed is a bit bigger, but if you need a fully 100% compliant, multiple componentry, full Kubernetes, then that's Charmed Kubernetes. MicroK8s, keep it simple, get running Kubernetes compliant tomorrow. So, questions?
So, when you went to deploy the MicroK8s cluster, if I'm not mistaken, you selected 3 nodes, right?
I changed it to 1 node, but yep.
Yeah. So, I didn't saw any option to choose a data center or something like that. So, physically speaking, where is this node? Is a virtual machine somewhere?
This is the benefit of now being able to do it live. So, pretty simple. You see here, can you read that? Kind of. Node count 3, enter 3 IP addresses for the 3 nodes.
Yeah, so where does these IPs come from? Is there any data center you maintain or what?
So the requirement here is that you already have some Linux VMs or servers running with SSH access. That's it. So we just SSH to the nodes and then run all the actual deploy commands. So
okay, so if I'm not mistaken, I need to provide Portainer access to my network, and you just assign.
Yeah, I should have been clear at the start. Portainer is self-hosted. It's not a SaaS service. You run it yourself. And it is a container. It's about 20 megabytes in size. It starts in about 3 seconds. So you can go, that single Docker run command, you go from that to using Portainer in a few seconds. So you run Portainer in your machine, like either on your laptop, on a server in your data center, and from that point, you then connect to, it's in your network, you then connect to any of your Linux VMs, and we'll configure them as a cluster for you.
That's interesting.
Yeah.
Hey, thanks for the chat. I just had a question regarding your proxy for the API server. Do you have any plans to support service accounts made in that cluster through that proxy? The reason I ask is I work on the Juju team. One of the problems we have is with branches, and Rancher has their own proxy server. Juju likes to go and create a service account, and they're the credentials that Juju ends up using for that cluster. They don't proxy through the Rancher's API, and so we call it the plug interface.
Yeah, so sometimes it's quicker to copy than to innovate. And so we saw what Rancher did, and we saw the pushback, so we didn't do that.
Yep.
So yes, we already proxy through the SA accounts. So you can create yourself an account through our proxy. We actually were the first organization to run the Kubernetes API conformance test against an API and for it to pass. So we just passed it right through.
I've got another question if you don't mind. With your you're saying CG add-on for G and stuff, do you guys support V6?
IPv6, yes.
Yeah.
Yeah. Not in this one. The statute didn't give no reason why we couldn't. But yes, we have supported IPv6 for about 4 years. We got called out publicly on some IPv6 wall of shame, and so I changed that pretty quickly. Same thing.
Tom hosts that website in his basement.
Right. The other thing we got called out for, and then I changed very quickly, was the SSO tax. So, for example, you'll see SSO is here by default. It's completely free as well. So we don't. SSO isn't a premium feature.
I do have one more question.
Keep going.
Do you guys support any, like, you're showing a little bit of federation stuff, do you support any larger federation stories between clusters, like any of the...
We don't have kubefed support at the moment, no. So each cluster is a single discrete entity, and we just take care of federated authorization, access, proxying. No service mesh fed, no kubefed. It's fair to say that I'm really interested in that. kubefed itself seems to have died off. There's actually a new project. CNCF's really weird. They've got multiple projects do the same thing. kubefed's kind of died, and there's a new one that's taking care of that as well. So, other questions?
So, could I follow up about the SSO? It's just for authenticating against the UI. Are
Correct.
you going to actually mount the LDAP to containers?
So when you connect Portainer's authentication, we have our own built-in auth, which I never want anyone to use. I'd love to remove it, but I can't. We have, once you connect Portainer to your external auth providers, from that point on, when you log into Portainer, you're logging in with that provider's, including any 2FA, multi-factor authentication, whatever you've got. That same user credential, we then create shadow accounts in the backend cluster. So when a user is created in Portainer, we automatically create them a user account in Kubernetes. And so when you log in through SSO into Portainer, we grant you access to the backend cluster automatically. So you don't need the OAuth plugin for Kubernetes. We do all that for you. Now we also make Docker useful, and we add access control and auth to Docker as well. So you've just got raw Docker hosts. You can get authorization and access control for Docker.
Yeah, another question. I see you, if you don't mind.
Keep going.
Okay, so I can assign the IPs to the nodes myself. Is there any mechanism to prevent creating, let's say, 2 clusters, but assigning the same node's IPs to different clusters? Or can I do that?
No, we haven't built that into the PR, but if we need to have a uniqueness detection, we have by name. Like the cluster name can't be the same, but we haven't. I don't see any reason why we couldn't. We've got filters elsewhere that ensure uniqueness. By the way, Portainer is about 100 mega memory max, the Portainer server. We had a customer who had tested us to 13,000 environments under management, and we got to about a gig of memory being used managing it. So it's all written in Golang back end, all React front end, so super, super lightweight. Other questions? You can ask me any questions about Kubernetes, not even Portainer.
That's a brave offer. That's a brave offer.
I've been living my life in Docker and Kubernetes now for 6 years. This is year 7 of Portainer, and we support so many people around the world. Our largest user base is US and then Germany. So lots of deployments. Heavily used in Industry 4 as well now. So because Portainer is so easy to use, OT engineering folk are taking to it like the duck to water. So it's pretty easy to use.
Well, in that case, I have what may be a little bit of a silly question, but right now, what about volumes, network volumes? We want actually to have them shared across some of these.
So we've got support for that already. So if you can come into a cluster, if the cluster is configured with a storage class, so in this case, this particular cluster has the built-in storage class. So if I turn this on and say allow access to host path storage here and hit save, I can now come into this one and I've got access to volumes, and I can actually come in and create persistent volumes, stateful applications, do what I want. If it's in the cloud and it's a cloud CSI driver, then you've got access to be able to create cloud block drivers as well. In Docker, the support for NFS and SIFs natively as well. And I think we are out of time.